There's nothing wrong with procedural programming. That's what people occasionally tell me when I use the term procedural code in order to imply that the code is bad. Sure, every problem can be solved procedurally. Of course, I mean, it's Turing complete. But procedural is almost always the wrong choice. Let me explain what I mean. Procedural programming works best when variation can be easily captured as data, when differences between cases are just differences in values, but when the algorithm stays the same. Some object contains the number 1, but another contains the number 3. Another object contains the number 42. And one object contains the character A, another B, and yet another C, and so forth and so forth. They all use the same algorithm, they just have different values for their variables. That's what parameterization gives us. But Sometimes we want the algorithm to change. Sometimes we want to do fundamentally different things in each of the different cases. Sometimes it isn't trivial to capture the variation as variables in an algorithm. So then we write completely different algorithms instead. Let's look at an example. Let's take a turn-based battle game as an example, something like the classic Pokémon game. In the game, a player selects between a number of different attacks, and each attack has a number of effects. Effects on the opponent and possibly effects on the environment. Let's make a simplified model of this idea of an attack. So we have the class attack with 5 fields: name, accuracy, damage, rounds poisoned, and makes contact. What are these? Well, name is the name of the attack, something like scratch or leer or whatever the attack is called. Accuracy is how often the attack hits, right? Because it can miss, so the probability of it hitting. Damage is the damage output of the attack, and rounds poisoned is, so in Pokemon, attacks can poison the opponent. And then the question here is, for how many rounds will that opponent remain poisoned after having been attacked with this attack? And then makes contact is a boolean, and that regards whether this attack makes contact with the opponent or not. Because some attacks in Pokemon make contact with the opponent, and some do not. And if the attack makes contact with the opponent, then the attacker can suffer some consequences as a consequence of the opponent having some abilities. Well, so what I mean is, if the opponent is a fire Pokemon and you are attacking that opponent by making contact, then you could get burned by that fire Pokemon, right? Because you're making contact. So this is why we need to know whether the attack makes contact or not, because the attacker might suffer consequences as a consequence of whether the attack makes contact or not. Okay. Moving on. Clearly, this is a simplification of the actual game of Pokemon. But parameterization captures variation as data. So different objects have different values for these properties, for these fields. So to make a kind of attack, we simply instantiate the attack class to create an object that corresponds to that kind of attack. Oh, and by the way, I mean, we're talking about using a procedural style in an object-oriented language. That's why I'm making use of classes and objects and not just of methods. Okay, so this looks fine, right? What's the problem? Why is this problematic? What are we talking about? Well, let's talk about 2 issues: readability and changeability. How easy it is to read and understand the code, and how easy it is to change the code. Both from the perspective of inside the class, but also outside the class, meaning for those that use the class. Let's first talk about what happens inside the class. So what's the readability of this class in this solution? Well, the class does too many things. And some things, like makes contact, will most probably involve a conditional, right? There will be an if statement. And other things like rounds poison could lead to conditionals, but depending on how we design other things in the system, we might be able to get around that. But makes contact most likely will become a conditional. But essentially, there's a lot of code in one place. So looking through all that code in order to find one particular piece of code that we're looking for becomes a challenge. So readability is quite low because there's just so much stuff so that it's difficult to find what we're looking for. Naturally, that also affects changeability. If it's difficult to read, to navigate, then it's difficult to make changes, especially without accidentally introducing bugs. We have this super long class trying to find the right place of making the change becomes a challenge. And if we're accidentally making the change in the wrong place because we have incorrect assumptions about what's going on, then we might accidentally introduce errors without realizing that we're introducing errors. And remember, we're talking about a very simplified version of a battle system from a game like Pokemon. If we were building the real thing, right, or something similar, we would have a lot more fields than just these 4 in our class. Right? I mean, in the game Pokemon, the monsters can be paralyzed, they can get burned, they can fall asleep. There's environment effects like rain, right? right? And there's more kinds of attacks than just contact attacks and non-contact attacks. So there's a lot of stuff going on. And the more stuff we put into this, the more stuff we add, the bigger these problems of readability and changeability get, the bigger this class becomes, the more difficult it becomes to find our way in this class. Okay, so let's now talk about what happens outside of the class. Now we talked about inside the class, but let's talk about outside of the class. When we're using the class in other places, how is readability impaired? Well, just think about how we would instantiate this class. The constructor will be super long, right? Even with the few fields that we have now, right, it's going to be pretty long. We might say something like this: new attack, and then we're passing in a bunch of values. What are the values that we're passing in here for these two examples? We're passing in the string scratch as a name for the attack. Then we're passing in 0.8 for the accuracy. Then we're passing in 20 for the damage. And then we're passing in 0 for rounds poisoned. And then we're passing in true for makes contact. And of course, we don't actually know what the constructor looks like, right? But we're just assuming that it maps 1 to 1, right? Let's say that that's what we have. Then how would we interpret this attack? This attack is something like this. It's called scratch. It has an 80% chance of success, right, of hitting. And it makes 20 in damage every time it hits. And it poisons the opponent for 0 rounds, meaning it doesn't poison the opponent. And then it is a contact attack because we're passing true here, right? So it is something that makes contact to the opponent. Okay, let's try to interpret the second one. What does the second one do? We say new attack, and then we're passing in a bunch of values. What are the values we're passing in? We're passing in breathe, all right? It's like the attacker is breathing on the opponent. Could probably make use of a better name than breathe, but whatever. Okay, so it's breathing, and it has a 50% chance of success. It doesn't do any damage, right? Because we're passing 0 here, but it does poison. When it hits, it does poison the opponent for 3 rounds. And then, of course, because it's breath, right? Because we're breathing, it is a non-contact attack. We're passing false here. So by knowing what the constructor looks like, we can figure out what these different attacks do. But even with just these 5 parameters, this feels a bit confusing, right? And just imagine if we had 20 parameters, 30 parameters. It'd be pretty difficult to read and understand at a glance, right? Okay, what about changeability? Well, here's where it gets really problematic. If we decide that we want to add a new idea that we haven't already built into the system, say we want to add the notion of getting burned for a few rounds, right? Something similar to being poisoned, but instead you're getting burned. Or something like an amount of damage that the attacker causes on itself, right? So that when we're attacking someone else, we're not just inflicting damage on that other individual, but we're also accidentally inflicting damage upon ourselves, right? So if we would want to add any of these concepts, we'd probably add 1 or more fields. But if we're adding 1 or more fields, then we need to add 1 or more parameters to the constructor so that we can actually construct objects with different values for those fields that we've just added. But that means that we're changing the signature of the constructor, which means that every piece of code that used to use that constructor is now broken, right? These 2 lines won't work anymore because they are passing 5 parameters, but now suddenly we have a constructor that has 6 parameters or 7 parameters or whatever it is. And yes, of course, we could use optional parameters or constructor overloading, but that only hides the underlying problem. The actual underlying problem is that every attack must express how they work, not only in terms of their effects, but in terms of every possible effect that an attack can have, now and in the future. Not only in terms of the effects that it has, but in terms of every effect that it could have. Think about that. That just seems like a really complicated way to think about this problem. Okay. So how would subtype polymorphism be better here? Let's look at it. Subtype polymorphism captures variation as behavior. Different subtypes have different implementations. Instead of forcing one algorithm to handle every case, we allow different cases to use different algorithms, as long as they share the same interface. So let's first separate the idea of an attack from its effects. So here we have one class called attack, one interface called iEffect, and then 3 subtypes, 3 implementations of the interface iEffect. And we're trying to model the same thing as we modeled before. Okay, so an attack still has a name, and it still has a probability, but now it doesn't have anything else. The rest is bundled up into this list or collection of effects. And what are these effects? Well, an attack has a, notice the has a arrow, right? Has a iEffect. Not just one, but many. An attack has many effects. Instead of bundling in the effects within the attack, we're saying the attack has a bunch of effects, and each effect is of type I effect. And so what are the subtypes of I effect that we currently have, right? Because we could have any number of subtypes in the future, but which are the ones we currently have? The ones we currently have are damage, poison, and contact. Okay, these are the effects. Damage has an amount field, because when we're making damage, we need to know how much damage we're making. Poison has a rounds field, because we need to know for how many rounds the opponent is going to be poisoned. And contact has no fields, right? Because it's just modeling the concept of coming into contact with the opponent. Now, could we have made probability an effect? Probably. Pun intended. We could probably also have broken out the idea of probability into its own hierarchy of things. Either a hierarchy of things that may or may not cancel the attack, or maybe a hierarchy of effect modifiers that could modify the effects before they are actually applied. We're really only scratching the surface here. But let's keep it simple, and let's keep probability in the attack class for now. So what do we gain from this refactoring? What do we gain from using an object-oriented style instead of a procedural style, which is what we had before? Well, let's look at the same two problems. What were they? Readability and changeability. Inside the class and outside of the class. So let's start with inside. What about readability? Massively improved. Massively improved. Why? Okay, because attacks are now extremely simple. When we use an attack now, all it does is that it checks if it's a hit or miss based on the probability, and then it applies the effects one by one by one by one in order. That's it. That's all that attack does. So it's very non-complicated. Okay, what about the effects? Is readability improved? Yes, massively. Why? Because now they are all focused on one thing and one thing only. They're separated. The damage effect just applies the amount of damage. The poison effect just activates the poison for this number of rounds. And the contact effect just tells the defender to apply the contact effects to the attacker because the attacker has made contact with the defender. But how does a damage object know what the amount of damage to inflict is? And how does a poison object know how many rounds the defender should be poisoned for? Well, the amount of damage and the number of rounds to remain poisoned are parameters of the constructors of those two specific classes. They're no longer parameters in the constructor of attack, and there's no constructor of I effect. So they're separate constructors for separate subtypes. What about changeability? Massively improved. To change or fix a particular effect, we only have to change that particular class. To make a change in damage, we make a change in damage. To make a change to poison, we make a change in poison, and so forth. No need to touch any of the other classes. And what if we want a new effect, right? Like we talked about before. Simple. We just add another subtype to the hierarchy of I effects. We write new code. This is very much in line with the open-closed principle because we are changing the program by writing new code instead of modifying existing code. By the way, if all this resonates with you, I highly recommend that you check out my book, The Object-Oriented Way. If you find this video interesting, you will definitely find the book interesting, and there's a lot more to dig into, right? Link is in the description. Check it out. Okay. So, what about outside of the class? Let's start with readability. Well, it's definitely not worse, right? The constructor might be called something like this now. Let's make the same two attacks that we had before. So here we have scratch, and here we have breathe. For scratch, we're saying new attack, and then we're passing in the string scratch, and then we're passing in 0.8 because the probability is 80% that it hits. We're building the same thing as before. And then we're passing in a list or an array, a collection, right? We're passing in an ordered collection of two effects. And what are these two effects? One is a new damage and the other is a new contact, right? Because what we're saying is that scratch is an attack that inflicts damage and the amount of damage it inflicts is 20, but it also makes contact. Okay, what about the other one? We're saying new attack, breathe. We're passing in breathe because it's called breathe. We're passing in 0.5 because the probability of it hitting is 0.5. And what are then the effects that we're passing in, right? We're passing in a collection of effects, and that collection only has one element. That's totally fine. We have a collection with one element. We could have a collection with 0 elements. That's totally fine. But here we have a collection with one element. What is that element? New poison. So we're passing in an instance of the subtype poison. And the number that we're passing into poison is 3 because the number of rounds that the target, the defender, will remain poisoned is 3 rounds. So yeah, I know there are more words, but it should also be fairly obvious what's happening here, right? In the first case, we have an attack that's called scratch that has an 80% chance of success. It does 20 damage and it makes contact. In the second case, we have an attack that's called Breathe that has 50% chance of success, and what it does is that it poisons the opponent for 3 rounds, right? It's fairly easy to understand when we're reading it. Now, if you looked at the previous solution and you were thinking about how to use optional parameters or named parameters, then I get that you might be a bit underwhelmed looking at the subtyped solution here. But if you weren't using those, then this is very obviously better. However, philosophically, this is where it gets really interesting. Think about the difference between what we have now in the object-oriented style and what we had with the procedural style. In the procedural style, every attack must express how they work in terms of every possible effect that an attack can have, now and in the future. But in this object-oriented style, an attack must only express what effects it actually has. It has to express its own effects. It doesn't have to say anything about the effects that it doesn't have. 0 and nothing is not the same thing. 0 is a value. False is a value. But what we are talking about here in the subtyped solution is the absence of a value, right? So from that perspective, the object-oriented code is drastically simpler because we can truly express the absence of a thing instead of being forced to represent the absence with a value. Pretty wild if you think about it. What about changeability outside of the class? Well, since we're no longer having to express the absence with a value, then the problem we looked at before entirely disappears. If you change the constructor of a subtype from the effect hierarchy, say damage for example, then the only code that has to change is the code that uses that particular constructor. Code that uses the constructor for poison or code that uses the constructor for contact won't have to change. So everything is better in every possible way, no? Yeah, I mean, in the dimensions that we looked at, definitely. But you know, it's a double-sided sword. As always, I mean, I never talk about performance. That's an entirely different conversation. I'm always concerned with shipping things that work fast. I'm not concerned with writing code that executes fast, right? That's a different conversation. But also, when you move to subtype polymorphism, you lose collocation. Right? We're spreading things out over multiple classes, over multiple different files. So, for example, if the battle mechanics in our turn-based game are extremely complicated, then we might actually benefit from just representing everything as data. When it comes to, let's say, balancing the game to make sure that all moves are fair, right? It might actually be easier to look at every move as data. Even if it's messy, right? It might be easier to have everything in one place. Could be. So as always, right? There's no silver bullet. Oh, and I forgot to mention that this video is sponsored by, well, no one, except me and my book, and it's called The Object-Oriented Way. So if you like this video, you will definitely like that book, so you should definitely check it out. There's a link in the description. Okay, I'll see you in the next one.